to be here. So my name is Benoît Rittaud. I am a mathematician. I'm working currently in Université Paris 13 in the north of Paris. And my specialty in mathematics is not linked in any way to climate. And what made me interested in the climate issue is not really mathematics, but the way science shows itself in this issue when science is mixed with politics or ideology. And well, I think it's an important point. Of course, a lot of facts we know are quite easily seen. In fact, well, for example, global temperature. We probably all know here that global temperature does not rise since the beginning of the century. If you put aside the El Nino, the last El Nino, it's quite easy to see, and even the IPCC acknowledges that, even if it says that well, the growth is not stopped but lowered. Also about sea level rise. I won't go further to what Niklas and Pamela said, of course, but it's quite easily seen. All of that is not really to agree about. About ice cap, we had a good presentation this morning, and all these facts shows that, sure, you can defend the greenhouse gas theory. It's okay. Science need competing theories. That's not the point. The point is that it is quite easily seen that this theory does not add up as well as it is asserted. So I don't want to talk about what could be the real driver of climate, of course. I have no idea. And neither do I want to talk about the consensus. I won't tell you that 97% of the most impressive scientists in the world agree with the IPCC. And I've said that there are a lot of honest and true scientists who know the field and stand with the IPCC. And this is, the exact number is not that important. The fact is there are a lot of clever people, honest people, and that cannot, do not acknowledge that science is not settled, simply put. So, in general, when discussing with a layman, well, I don't know if every one of you has the same experience, but in general, layman people are very open-minded, and in general, more open-minded than scientists, unfortunately. They agree that it is useful to discuss, that we are not supposed to agree with what's been said by others. And but when giving them scientific arguments about temperature, sea level rise, etc., polar bears, and so on, in general, most of people understand the argument, get the fact that everything is not that simple, but eventually comes with another kind of very different kind of arguments. For example. Should we apply precautionary principle? Or how can it be? I said that so many clever people disagree with some apparently so basic facts. And well, anyway, shouldn't we care about what's going on the planet? And I remember when we were in London during the geoethics conference organized by Niklas and Pamela again. There was one question that were asked from a journalist who was not involved in the debate, and it was, I think, the question that attracts the most kind of answer is that was the question: are there historical examples of other scientific controversy with the same importance as the climate issue? And several people tried to answer and propose possible answers. I think this kind of question, we should address this as climate realists. It's very important. Of course, we have first to say that science is the first battlefield. But this is not the only one. And in general, I'm not sure that we as climate realists are sufficiently taking this into consideration. But I can tell you that on the other side, on the IPCC side, they understood quite a long time ago that a perspective on what science is, about the way science evolves, is really considered as important. I could tell you about several social scientists in France that provide weapons to them, but we do not. And for example, for the record, I would like to mention one recent example. It is an interview given in Science magazine in October by the French social scientist Bruno Latour. Possibly some of you know his name. He's quite famous in France and has some faith also in the US. And here is the quote. So Bruno Latour says, he's a IPCC side, of course. We are indeed at war. This war is run by a mix of big corporations and some scientists who deny climate change. They have a strong interest in the issue and a large influence on the population. So, okay, that's standard discussion. And the question of the journalist is, how did you get involved in this science war? And he answered, it happened in 209 at a cocktail party. A famous climate scientist came up to me and said, can you help us? We are being attacked unfairly. Claude Allègre, a French scientist and former Minister of Education, was running a very efficient ideological campaign against climate science. And now listen to this. We could take it for us word to word. It symbolized the turnaround. People who had never really understood what we as science studies scholars were doing suddenly realized they needed us. They were not equipped intellectually, politically, and philosophically to resist the attack of colleagues accusing them of being nothing more than a lobby. I think it's perfectly said. And to emphasize on this, I want to say that it is very unusual for me to confess that Bruno Latour can be right about any subject. But for this, he's perfectly right. And we climate realists, we should consider more this aspect of the climate issue. So I would like here to mention some, let's say, climate realist-sided epistemology to counter the one which arose several years ago in France in particular, in several laboratories, but not only, and which are useful and are used really as weapons to fight against climate realisms. For example, we have something to say between the difference between science and ethics. And I owe this to Vincent Courtillot, which is a French geologist, about the naive naive will to be good to the planet in general. So we hear very often, even in scientific circles, that, well, climate is to be good to the planet, to make good to the planet or an habitant or wealth of humanity. And of course, we can say, well, this is not that simple because wealth, energy policies does not work very well, and it is more difficult than you think. And we can counter, of course, the argument in this way. The point is that the real problem lies before that. The real problem is that you cannot confuse science with ethics, because science has to do with what is right or wrong, in short. And ethics is concerned with what is good and what is bad. and it is totally different. We have the choice to decide that something is good or bad, but we do not have the choice to decide whether something is true or not. And I think it's an important important argument to avoid to quit science, and we have to stand to science. So we have to say, I do not choose to be climate realist because of my general opinion on life, my Weltanschauung, but I choose it because it is what it is. We do not have choice, simply. Also, there is a more epistemological arguments that should be taken in consideration by our side. And for example, several years ago, I debated with a physicist, a French physicist, quite known in France because he's a quite famous popularizer. His name is Etienne Klein. Maybe well, other people, non-French people, probably don't know about him. And he's from the IPCC side. And we debated. It was an accidental debate, very short debate. And he said, well, you skeptics, you're not real scientists because you use a wrong argument, a trivially wrong argument, which is you say, we cannot predict the weather 10 days in advance, so how dare can we pretend that we will predict the climate a century in advance? And of course, he's speaking, Etienne Klein speaking, see, of course it is a wrong argument, since even, of course, we cannot predict the weather 10 days in advance, butterfly effects and so on. But as for the climate in the next century, we perfectly know that July will be probably warmer than January. So being unable to make prediction 10 days in advance is not an argument to say that we cannot predict the weather a century in advance. But this counter-argument he provided is totally wrong. Is even worse than the initial argument, which is indeed quite rough, quite rude. The point is that meteorological models cannot predict the weather 10 days in advance, and climate models that derives from meteorological models cannot, hence, cannot pretend predicting the weather a long time in advance. But the fact that we know that July will be warmer than January in one century is not due to climate model at all. It is due to mathematical astronomy of ancient times. So it is a kind of epistemological usurpation to say that we know things, so you can be confident. You don't know things. It is not you that did this prediction. It is the ancient Egyptians several millennia ago, and for agricultural reason, invented what we call the Julian calendar for agricultural reason and also fiscal reasons, since for taxes you have to wait the farmer and the harvest has been done. Another kind of argument, which is very common and which is quite painful for a mathematician, is the repeated use of Pascal's wager. In a modern way, Pascal's wager is about, well, even if we're not sure that climate is going bad, the consequences would be so painful that we cannot take that risk, and we have to do anything that we can. This is a modern version of a text by Pascal, written in the 17th century. Pascal is a really good thinker, one of the most important thinker in the 17th century. Is very renowned for being a philosopher and a scientist. and among his contribution, there are also theology and mathematics. In mathematics, he is the first to have acknowledged the importance of probability theory. He's not the first to make some calculation of probability. Before him, there was Cardano, who made also several calculations, interesting calculations, but it was always restricted to, well, throwing dice or well, playing cards or things like that. Pascal is the first to understand that it is much more important and mathematical theory of probability. That means you can study mathematically randomness. It's very strange, and he was the first to understand that it was strange, but it was possible. And as far as I know, the first application of that, the first application of probability outside the field of games of chance was theology, again by Pascal. Pascal says, well, should I believe in God? This is the first question, non-trivial question asked to probability theory. And he says, well, I don't know, maybe God exists, maybe not, but there is some probability that that he exists. And to make my choice, I will, to make the choice, we have to think of it like if we were playing cards or throwing dice. Evaluate the gain compared to the probability. And the calculation, which is in some sense exact, is, well, I multiply the probability by the gain, by the reward, if God exists. And I compare this product to the bet. The bet is my life. So the reward is eternal life. And the argument is, well, the probability that God exists may be very small, but when multiplied by infinity, it is still infinity. So it is bigger than the initial bet of only one life. So we should all believe in God. That's a very good application of probability theory indeed. And the fact is that we had to wait till the middle of the 20th century to understand why this argument is false, mathematically speaking. It was proved to be false by Émile Borel, a French mathematician. You see that Pascal's wager is of same nature than its modern version in terms of precautionary principle or things like that. Indeed, it's quite difficult to understand exactly why Pascal was wrong, why in a mathematical way. And it reminds me a quote by a philosopher named Alain, who wrote that, in general, a mistake is a good start for thinking. And indeed, Pascal's wager is mathematically wrong, but very, very interesting to study. Its mathematical form is very interesting to study. I won't explain you why, mathematically speaking, Pascal's wager is incorrect. But what I can still say is that, well, every year, all the time in the university, students, when studying modern integration theory, learn that when a function is equal to 0 almost everywhere, then its integral is also equal to 0. This is the main argument against Pascal's wager. I won't go into this. But what I would like what I would expect from my colleagues is that, well, when this theorem is stated, every colleague should say, okay, so that proves that Pascal's wager is incorrect. That proves that precautionary principle presented that way is not, well, I say incorrect. It's not incorrect, but it's just not mathematically sound. It's something else. It's not science. It's just a way of making a choice. But it's not science. It's not mathematically founded, even if it was raised up by Pascal. But in general, none of my colleagues even never did that. And suppose I come into the room at that time and say, hey, François, could you tell your students about Pascal's wager? I suspect that the answer would be, could you first remind me what Pascal's wager is? And so we have the problem well, that's, in this case, it's a problem from the mathematical community, is that we do not we did not pay enough attention to this kind of thing. Think, for example, at physicists. Physicists discovered 1 century ago that we cannot have, well, the speed of light is an upper limit, and we cannot go faster than the speed of light. Okay, everybody knows that. Everybody accepts that. Even if we do not know how to prove that, we know that it's true. And even Hollywood take care of this. And you would not see a spaceship going faster than the speed of light, well, or in a specific way. But we do not have. We did not the job, we mathematicians, about Pascal's wager. I would like to see a day in which, well, when in a debate somebody tells about, well, we're not sure, but if it happens, so we cannot take that risk. I would like the other to reply, Pascal's wager, end of discussion. You're outside of the science. You just give a feeling, but not a scientific argument. Well, so to be more specific to the climate issue, what's very interesting, and well, of course, about climate issue, we can well, when we understand that there is something wrong with it, we tend to say, well, let's fight against that. And sure, there are things to be done, but there is also we need also to try to understand what's going on, without saying it's bad or good, but just describe the phenomenon. And I think that it has to do with pseudoscience. The word we already heard about pseudoscience this morning, and it is indeed what's happening now. Why so many scientists can believe this story? And is it the first time we see such kind of thing? Both of these questions can be answered partly by considering history of pseudoscience. First, what is pseudoscience? It is a question which is not, which is seldom asked. In general, we ask for what science is, as Popper did, as Karl Popper. Popper wanted to define science and proposed this famous criterion, that is, a theory is considered as scientific if and only if it is falsifiable. But Popper, somewhere else in another book, wrote also an important thing, is that you can never know when a theory is true. Because, okay, it works whenever you test it, but what proves that tomorrow a fact will prove otherwise? So you cannot know that a theory is right, but you can know that the theory is false. It suffices to find a counterexample or problem. And I think that this idea, this very powerful idea, should apply to the definition of science itself. We cannot define science, in fact, but we can define pseudoscience. It's easier. We can show that something is false in some sense. And if you read about the common definition of pseudoscience, it's in general, well, it is not done in academic circles. It's this kind of formal elements, and I think we need a deeper argument. Why? Because pseudosciences are not done only by strange people that know nothing, but also by scientists themselves. I'm a mathematician, so let's see mathematics. Mathematics, one of the founders of modern mathematics was Pythagoras. Pythagoras in the 6th or 5th century before Christ. Pythagoras was not only a mathematician, he was also a mystic. He created, he did possibly, but we don't know much about that, in fact. He possibly did some mathematics, but he also did what we would call nowadays numerology. And when you read really what he did, or what his school did, because we don't know exactly who did what. It was a mix between science and pseudoscience. And it's very common. Take any field, and you get this correspondence. Science goes with pseudoscience. And moreover, in general, pseudoscience precedes science. Take astrology and astronomy, for example, etc. Any scientific field has this phenomenon. And pseudoscience is also created by true scientists. Pythagoras was indeed, he said, everything is numbers. That's a powerful idea, very modern idea. So it's a scientific idea, but he also did numerology. Take Kepler for astronomy and astrology, or Al-Biruni also, a lot of other people. Well, in general, pseudoscience is created by scientists. And this is what we can see today. So it's very interesting. If you're interested in this epistemology, you have the birth of a pseudoscience. Nowadays, the pseudoscience of pseudo-earth sciences, if you want. And what allows me to say that is the fact that the criterion to distinguish pseudoscience with science is that take astronomy and astrology, for example. Astronomy is sound science. You're studying the sky, motion of planets, sun eclipses, etc. And astrology also take the planets in consideration. But the purpose is totally different. The purpose of astrology, and more generally of pseudosciences, is to say something about us humans. And the sky is nothing more than an instrument, a tool, to say things about us, which is your astrological sign, well, what will be your future, etc. The distinction between mathematics and numerology is of the same kind. In mathematics, in number theory, we study numbers for themselves. But in numerology, you take the letters of your name and you do so and then you get a number, and it is your number, and it tells you that you have this characteristics in your mind. So here we have in IPCC science, say, we have the fact that climatology is not studied for itself to describe climate. It is intended to tell something about us. We are bad. We are making useless to say, but it is intended to talk to us. It's a mix between, instead of studying an object, a scientific object, it is in fact interested into individuals, us, humanity, or whatever you mean. And this is, for me, is the real criterion with which you can distinguish between chemistry and alchemistry. Or even, you can also see that when there, in almost all part of science, there is some momentum in which science and pseudoscience separate. For astronomy and astrology, it's maybe Copernicus or Galileo. Galileo once said, planets are not beings, they are things. And if you read Claude Bernard in Introduction to Experimental Medicine, he also says, well, to do medicine in a scientific way, you have to consider the body as an object, not as a subject. Even sociology, you can read Émile Durkheim started his book, his fundamental book on sociology, by saying we have to consider society as an object. And this is, in general, the momentum. When this separation occurs, then we can say, as for me, that science, that precise part of science becomes modern. And nowadays, the climate issue shows that climatology is not modern in this time. It is still archaic. It's not, I don't want to make fun of it. There is a time science has to start. It is difficult to know what questions are of a scientific nature on which questions are not. And for example, debates around astrology before Copernicus or Galileo was indeed interesting debate. It was not easy to dismiss astrology as a science. There were sensible arguments. It has to, well, something had to occur to make this separation. So I think that we can hope that someday there will be a sort of Galileo for climate, which will clearly say, now we want to do climatology. We do not want to save the planet. These are two different questions. Sure, we know that this is not the same question, but it is not just a two-linked thing. It has nothing to do the one with the other. Ask an astronomer today to say to tell you about your astrological sign. He will kick. He will say to you to go away. Tell a climatologist today, well, what do you think about the future of our planet? Do we do well or not? He will do okay. He will reply, well. He will not say to you, this is really another problem. Go away. I don't want that. It's because this separation is not done exactly at least for climatology. And eventually, we also have the question of, in a more general framework outside of science, is the fact that, so many people outside of science believe in this scary story about climate. And it is not only a small circle. Well, it's not like a debate about astrology and astronomy that we could have in the medieval period. It's really the whole society which is concerned. And we have to also study that. How can this story, which is a quite nice story indeed, could get so much support in all level of society? And there is probably no simple explanation to that. And historians of sciences will have a lot of work in the next century to understand that and to figure out what happened. But one aspect which is interesting, at least for a mathematician, is that there is a common word on several of these fears that the society has since, let's say, the 60s or 70s. And this specific word is the following one. Before saying it, imagine you're in October 1968. You're the editor of Science, the journal Science, the most renowned scientific journal in the world, or so. October 1968, and you write an opinion piece in Science that starts by the inexorable, the toughest enemy is. What should we put after that? In October 1968, what is the toughest enemy of mankind? So at the time, it's several months after the Prague Spring. Vietnam War is in its fourth year, etc. But for science, the toughest enemy is the inexorable exponential, a mathematical object. And indeed, it is written in 1968, and it was very prescient of what would happen after. Because now the concept of exponential has become the scientific background, if I can say, the scientific background of most of our global fears. You know, global fears the global fear in the 70s was mainly about demography. It was written that, the population of the Earth was increasing exponentially fast. And it is also that at that time that we saw for the first time the picture of the Earth seen from the space. And for the first time, we really saw the finiteness of the Earth. And I think that is the conjugation of both phenomena, seeing the finiteness of the Earth on exponential fear, that created a lot of well, a general background that made society interested into this kind of stories. Because our world not only is finite, as suggested by these pictures, but it also becomes tight because of our exponential growth in any form. And several years ago, it was used in climate, for example, by James Hansen, who wrote that, well, he imagined that, I don't remember exactly the figure, but he talked about the melting of Antarctica. Okay, as you know, Antarctica will melt very soon, in 1 century at most. And how to say that? But he said, well, the last decade, it contributes to 1 millimeter of sea level rise. And the next century, it was 2. So next decade it will be 4, then 8, then 16, then 32, etc. And in 1 century you get 5 meters of sea level rise. Okay, and it's not in a TV show. So he said that it is published. It is even published twice. So climate for me is as this the actual exponential fear. It's not only that, but it's also that. It is the idea that we are growing exponentially, and since our world is finite, that it's going to explode soon. And there is a lot of things to be said that goes back to, well, Malthus in the end of the 18th century, but even before. Well, the idea that the exponential growth is a kind of magic is very common, and we can track it till at last the 17th century or even before. And so it is also a kind of pseudoscience, of pseudo-mathematics, that makes use of a concept, a general concept, exponential, which is quite striking because you all know about the story of the grain of wheat we put on the square of a chessboard that grows and grows, and the fact that it is psychologically difficult for us to conceive how fast an exponential growth can be is used to create nowadays it is used to create fear. Before it was created to, well, it was more an optimistic way of things, saying things. If I say that, it's because I think that climate fear will eventually collapse, but exponential fear is more deep, and probably we will have to, when the climate issue is gone, probably it will be the beginning of another exponential fear, another pseudoscience. And it is also our duty, I think, to make sure that this does not happen in the future. Thank you for your attention.